Welcome to GMAT Math Online Math Prep videos. In this GMAT Math Online video, we explain how to solve percentage problems. We start with problems that can be solved using equations. As always, we set up an equation by letting the unknown, usually x, represent the value we're trying to determine. Here's an example. Arlen gets 10% commission on his total sales above $2,000. He gets no commission on sales up to $2,000. If he was paid $900, what were his total sales? And here are some possible answers. Let's find the solution. Let x be his total sales. Then 10% of x minus 2,000 equals 900. So that 1/10 times x minus 2,000 equals 900. And therefore x minus 2,000 equals 900 times 10. And finally x equals 9,000 plus 2,000, which equals 11,000. So the correct answer is D. Problem. 90% of the shareholders of a company have owned shares for 5 years or more. Of those, 60% have owned shares for 5 to 7 years, and 20% have owned shares for 8 to 10 years. 900 shareholders have owned shares for more than 10 years. How many shareholders are there altogether? Here's a summary of the facts of this problem. Let's find the solution. Let x be the total number of shareholders. These can be divided into 4 categories: those who have owned shares less than 5 years, 5 to 7 years, 8 to 10 years, and over 10 years. Category 1 constitutes 10% of shareholders because the other 3 categories are 90%. Category 2 constitutes 0.9 times 0.6, which equals 0.54, and that's 54% of shareholders. Category 3 constitutes 0.9 times 0.2, which equals 0.18, and that's 18% of shareholders. Category 4 constitutes 0.9 minus 0.54 minus 0.18, and that equals 18% of shareholders. And we know that Category 4 has 900 shareholders. So, 0.18x equals 900. Therefore, x equals 900 divided by 0.18, which equals 5,000. Now let's look at inequality problems. Inequalities are concerned with determining ranges in which a given value might lie. As with equations, we let the value we're interested in be designated by a variable, say x, and then we formulate the inequality using x. Here's a sample problem. In a certain state, between 0.4% and 0.8% of new companies will fail in their first month of business. During the year, 8,000 new companies started operations. Which of the following numbers is in the range of the number of companies that failed during the first month? Here's a summary of the facts of the problem. And here are some possible answers. Let's find the solution. This problem can be a little deceptive because it says 0.4% and 0.8%, and our natural inclination is to interpret that as 4% and 8%, or as 4/10 and 8/10, which would be 40% and 80%. But the actual numbers are less than 1%, which is less than 1/100th. So we have to treat them in that way. We apply 0.4% and 0.8%, therefore, to the number of 8,000 new companies to find out how many failed. Let x equal the number of new companies that failed in their first month. We start with this inequality. X is greater than or equal to 0.4% of 8,000 and less than or equal to 0.8% of 8,000. Therefore, x is greater than or equal to 0.4 divided by 100 times 8,000, and less than or equal to 0.8 divided by 100 times 8,000. And that implies that x is greater than or equal to 4 divided by 1,000 times 8,000, and less than or equal to 8 divided by 1,000 times 8,000. So, x is greater than or equal to 4 times 8, and less than or equal to 8 times 8. Thus, x is greater than or equal to 32, and less than or equal to 64. The only number in the list of possible answers which is in this range is 45. So the correct answer is B. Now let's look at abstract problems. Often we need to get the solution to a problem in terms of one or more variables, rather than as a literal value. This tends to be confusing because we usually prefer to think in terms of the concrete, rather than the abstract. But this is an important skill to master, so problems of this type are discussed here. In this case, we still must designate some variable as an unknown, and as before, we make it equal to the value we're seeking. But our unknown is determined by solving the equation in terms of the other variables. Here's a sample problem. County S averages X inches of precipitation annually. In a 15-day period in April, County S averaged 0.3 inches of rain every day. What percentage of the annual average did they get during these 15 days? And here are some possible answers. Let's find the solution. 0.3 inches of rain per day for 15 days amounts to 4.5 inches. So the question now is what percentage of X is 4.5? Let P be the percentage we're interested in. We need to calculate P in terms of X. Remember that since P is a percentage, we need to express it as a fraction, where P is divided by 100. So, P divided by 100 times X equals 4.5. Then P divided by 100 equals 4.5 divided by X. Therefore, P equals 4.5 divided by X times 100. This is easier to see if we use a simple example. Suppose the annual average of precipitation is 9 inches. That is, X equals 9. Then 4.5 inches equals 1/2, or 50% of the annual average. That is, P equals 50. Let's plug that into our result and see what happens. P equals 4.5 divided by X times 100. So P equals 4.5 divided by 9 times 100, and P equals 1/2 times 100, and finally P equals 50. This is the tricky thing about working with percentages. When we say 50%, we really mean 50 divided by 100. But if we just use 50, then that's very different from using 50 divided by 100. Thus, we have to be very careful to use these percentages as fractions whenever the problem calls for it. So the correct answer is E. Now we'll see how to solve percentage problems using systems of equations. It's often easier to determine the solution to a problem if we use multiple unknowns in multiple equations. Usually, 2 equations in 2 unknowns suffice. This may be true even if we're only required to find the value of one of the unknowns. Here's a sample problem. Of 3,468 airline passengers, the number age 60 and over was 30% less than those under 60. How many passengers were age 60 or over? And here are some possible answers. Let's find the solution. We add the number of those 60 and over to the number under 60. Let X equal the number 60 and over, and Y the number under 60. Then X plus Y equals 3468, and X equals 0.7Y. So 0.7y plus y equals 3468, and 1.7y equals 3468. Thus, y equals 3468 divided by 1.7, and y equals 2040. So, substituting this value for y into the first equation, we get x plus 2040 equals 3468, and therefore x equals 1428. Just as a check, 0.3 times 2040 equals 612, and 2040 minus 612 equals 1428. So the correct answer is D. Finally, let's look at the arithmetic of percentages. In performing computations using percentages, we must constantly bear in mind that percentages are simply fractions that have a denominator of 100. Problem: what is 1 minus 50% of 50%? And here are some possible answers. Let's find the solution. 50% of 50% is 1/2 times 1/2, which is 1/4, and 1 minus 1/4 equals 3/4, which is 75%. So the correct answer is D. Problem: what is 50% plus 0.2 times 50%? Here are some possible answers. Let's find the solution. These problems tend to be a little confusing because we forget that percentages and decimals are just fractions. Knowing that 50% equals 50/100ths, which equals 1/2, helps us to solve these problems. So in this case, 50% plus 0.2 times 50% equals 1/2 plus 2/10 times 1/2, which equals 1/2 plus 1/10, and that equals 5/10 plus 1/10, which is 6/10, and that equals 60/100ths, which equals 60%. So the correct answer is B. For more practice on GMAT problems, see our other videos and go to www.gmatmath.online. And you can get our ebooks, GMAT Math Basics, GMAT Math Problem Solving, and GMAT Math Data Sufficiency. Thanks for your interest.